Hi all, welcome to Learn Code Repeat. So today's problem is the day 6 problem of LeetCode September challenge. This problem has been asked a lot by Google and Amazon. The name of the problem is image overlap. Let's look into the problem. The problem is image overlap. So the problem statement is two images A and B are given, represented as binary square matrix. So that means the matrix is of 0 and 1s. And we need to translate one image such that we have to place it on top of the other image. After the overlap of this translation is the number of position that has A1 in both images. So that means this is the matrix and this is the second matrix. So there is matrix A and matrix B. We need to place or overlap matrix B on top of A or A on top of B such that the number of ones should be maximum. The count of the number of ones should be the maximum. Let's take this example. Here we have the two matrices that have represented. The black one is the A matrix and the B one is the blue matrix. So what they have asked is we have to place either of this matrix either. So here I am placing the blue matrix on top of A such that when I place it on top of it, so the numbers, right, 0 1, it should occur the most number of times. So here if I place exactly the 0th row and 0th column of matrix B with matrix A, right, that is the blue one with the black one, I see only in the middle row, right, middle column and middle row, it is both 1 1. So here the output is 1 for this particular case, right. Now this x and y axis, right, what we have said here is the question says that you can go up or down or left or right, right. So up and down action is the y axis action, we can go on the y axis up and down, and x axis is the action of left and right, right. So that means x axis represent the columns in the grid and y axis represent the rows in the grid, right. So you have to be very clear here because most of the time during the interviews normally we confuse between x and y. We take x as row and y as column. So whereas here x is actually the column and y is the row. Okay. So what the question is saying that we have to just find out the maximum number of occurrences of 1 where both the matrix are having the same value of 1, not 0 but only 1, right. So here it's 1. Now one approach is that I overlap it exactly on top of each other and then go either right or go down, right. So that means what I am doing is I am keeping one matrix as still and the other matrix is the one that is shifting, either it's shifting right or shifting down, right. Similarly it can shift up and it can shift left, right. So let's take the condition, right, where this is shifting right and this is shifting down. Let's take that condition, right. So if I keep it on top of here, the values are only one cell is there where both the matrix is having the value as 1. Then I will move to the next column on the right, right. Here there are no rows or no cells where it's overlapping but the values are both 1, right. So the first column of the black matrix, right, we don't have to consider that because there is no overlap there. So we can ignore this column, first column, and then we can consider the second and third. So here there is no 1 1. Again it will move, we will move one column right, the blue one. Again we will consider only the overlaps cells and there is no 1 1. So this is done. So now we will again go back to our first column, but this time we will move one row down. Okay, so we will consider this way. So now here if you see the overlap is only second and third row of the black matrix. Okay, so the last row of the blue matrix we should not consider because that is not an overlap. Okay, so here if I see only the third row and second column is having 1 1 for black matrix, right. So here also the number of occurrences is only 1. So I will go now to the next column. Okay, I will perform the same operation that I performed for first row. So I am performing the same operation for the second row, but this time the shift is the blue matrix is shifted down and then I've moved it to the right. So here there is no rows or cells where it's both 1. Here also there is no cells with 2 1s, right. So this row is done. Now again I'll go back to the next row, right. Here I'll only check the overlap rows where both the matrix is overlapping, and so for this case there is 0 cells which have 1 1. Again I'll move to right. Again there is 0 cells which is 1 1. Again I'll move to right. So there is 0 cells which is 1 1. So that way we are done with this, right. So we moved down and we moved right side, right. So that is the operation that we performed, and the max count of cells where we have both 1 1 is only 1 till now, right. So now what we did for moving down and moving right, the same thing we can do it for moving up and moving left, right, or moving up and then moving right. Okay, so moving this blue matrix up is same as keeping the blue matrix still and moving the black matrix down, right. So I'll keep this still, and so if I move the blue matrix up, right, I'm getting this, right. This is the combination where the second row of the blue matrix is coinciding with the first row of the black matrix, right. So if I keep this still, blue still, and I just move my black matrix, right, as down, right, here also it's the same combination that I'm getting, right. It's similar to moving the blue matrix up, right. The reason why I'm showing this is because instead of doing earlier with the blue matrix, what we did is we moved it down and then we moved it to the right. Now instead of again moving the blue matrix to the up and then right, we can do the same operation with black matrix, right. So when you are doing the for loop, we can first do one move down and then right for the blue matrix, and then we'll do the same operation for the black matrix. I'll show that during the code, the trick for doing that instead of again going up and then right for the blue matrix, right. And similarly taking the blue matrix to the left, right, is same as taking the black matrix to the right. So the same trick we can apply here. We'll see that in the code, right, how we can do that. So that way we don't have to move in all the 4 directions. We can just move in only 2 directions, that is move down and move right, but we can swap the matrix, and that will take care of moving in all the direction. Okay, so let's see the code, what it is, right. Okay, so as I said, first we'll have to go over the rows and columns, right, for the shift, right. So let's say this is int row shift 0, shift is less than a dot, it's a n by n matrix, right. So the columns and rows will be of same length. Okay, now here, so what we are doing is for each shift, right, we are going over the rows and column, right. So here, right, before using the blue matrix, I am going over the black matrix rows and columns, right. Now after this I need to go over the blue matrix rows and columns, but the blue matrix, if you see here, right, in the blue matrix we only need to cover, if the blue matrix is overlapping like this, we need to cover only the overlap section, right, overlap area. We need not cover the areas in the non-overlapping, right. For example, here it's column 1, right. So here I am adding one more let's say counter, int count equal to 0 and count equal to mat.max of, and I am calling a function shift count. So in this function I'll pass a, b, and whatever is my current row shift number and column shift number. Okay, and I'll quickly define this shift count. Okay, so I have defined this function, and what we'll do here is we will go over the same for loop. I'll just copy it from here, but it won't start with 0 this time. So this is, let's say, okay, so this is a row equal to, I'll start with row shift, and a row is less than a dot length, a row plus plus. Similarly here it will be a column is less than a dot length, and again a column won't start with 0, it will start with call shift. Okay, and yeah, so this is where I'm going through each and every rows and column for my A matrix. Okay, and I'll check whether my B matrix, right, my B matrix I'll always start with 0, right? So let's say my B row is initially at 0, and here, right, in B call equal to 0, my row and column will be 0. Okay, so I'll only check here if A of a row and a call equal to 1. So I just need to do it only when my fixed matrix, which is A, right, it's having the cell value as 1, only then I need to do the comparison, right? So, and my arrow is 1 and my arrow of this equal to B of my B row B call. Okay, so that means both the matrix is having 1. In that case I'll increase the counter. Okay, and once I've done with this, I'll increase the B call. So once this is done, I'll also increase the B row, so that I increase the row as well. And here it will give me the count of this, so I'll return the count once this is done. So for each case I'm doing this again and again, going over the overlapping sections and returning the count wherever both the cells are 1, right? So here it will do for each and every row and column. Within that also again it will do for each and every row and column, right? So once this is done, now here, right, as we said, right, we are only moving right and to the bottom, right, but we also need to move to top and left, right? So as I said earlier, it's same as swapping the matrix, and instead of passing this as a shiftable matrix and keeping the black one as fixed, we can shift black matrix and keep blue one as fixed, right? So in the code we only need to do this. I'll copy the same thing, and instead of passing a comma b, I'll change the position and pass b comma a. So that way one will be fixed and the other is non-fixed. So here a will be fixed and b is non-fixed, and here b is fixed and a is non-fixed. Okay, so that's what we are doing here. Okay, so once we are done with this, at the end we'll have the value of the number of cells which can be shifted, such that this will return me the max number of cells with value 1. So let's run the code. Okay, so for this it's working fine. Let's submit. Okay, it got accepted. Okay, so the complexity of this algorithm is, here we are doing 2 for loops, and within that we are again calling shift count twice. So here again there is a 2 for loop, right? So here the complexity will be n raised to 4, and since we are not using any additional space, so the space complexity will be O of 1. Hope you like this video. Please like, subscribe and hit the bell icon to get future notification for such videos. Thank you.